heard of the term binomial expansion? Sounds interesting, right? Let's see what it is. Wait, first let me ask you a simple question. Do you know what a binomial is? Is x squared a binomial? Or is x plus y plus z a binomial? No, they're not. Then what is a binomial? In simple words, a binomial is a polynomial which is a sum or difference of only two terms. For example, say x plus y squared or x squared plus y cubed. Are they binomials? Yes, you're right, they are, because they consist of only two terms. Let's try and solve this one question. Give it a shot. How do we solve this? Do we multiply 103 with itself? Of course we can, but let's try another method. Can we write 103 the whole squared as 100 plus 3 the whole squared? Will it do? Surely, why not? Both these values are equal to each other. Now we all know the formula of a plus b the whole squared, right? Can you tell me what it is? Yes, it's a squared plus 2ab plus b squared. Hence we can apply this formula and get the answer of 103 the whole squared as 10,609. This method is much simpler as compared to multiplying it the regular way. Now consider the same number, but this time let's change the power to 3. This is 103 cubed. How do we proceed now? Yes, you're right. We do it by using the formula of a plus b the whole cubed. This is the formula. So we can write 103 as 100 plus 3, substituting 100 in place of a and 3 in place of b. We get the following answer. Again, easier than multiplying it the regular way. These two formulae help us find the answer easily. But what if it was 103 raised to 7? What do we do now? It's surely not feasible to multiply 103 7 times. So what's the solution then? Do we know any formula for it? We probably don't. That's exactly where binomial theorem comes into picture. It helps us expand such terms with higher powers very easily. Say we have x plus y raised to 7 or we have x minus y raised to 9. Such expansions can be done very easily using binomial theorem. So what is the binomial theorem? Yes, it's permutations and combinations. We will be requiring only combinations here. We all remember the formula of combinations, right? Yes, it was NCR equals n factorial over n minus r factorial times r factorial. What does NCR mean here? NCR represents n items taken r at a time, where the order in which the items are chosen does not matter. Now, let me ask you one question. Can you tell me the value of 2C0? Yes, we can use this formula. We get it as 2 factorial over 0 factorial multiplied by 2 factorial. We know that 0 factorial is 1. So we get this value as 1. Now by using the same formula, can you tell me the value of 2C1? Yes, it's 2. Now try getting the value of 2C2 as well. Do you get it as 1? Yes, that's right. We got the three values as 1, 2, 1. Say we have to expand the binomial a plus b raised to any positive integer. We know that to get the binomial coefficients, we can use the formula of combinations. But how do we get the other terms consisting of a and b? What do I mean when I say other terms? Take these two identities for instance. Now using the combination formula, we will get 1, 2, 1 and 1, 3, 3, 1. But what about these parts? Let's see. Look at the formula of a plus b the whole cubed. Observe the first term. Can you tell me the power of a here? Yes, it's 3. Now tell me the power of a here. It's 2. And what's the power here? The power is 1. Now, what's the power of a in the last term? The last term does not have a at all. This means that the power of a here is 0. So it's 3, 2, 1, 0. Now let's look at b. Can you tell me the power of b in each term? Yes, they're 0, 1, 2 and 3. Didn't you notice any pattern in the powers of a and b? Yes, we observe that the power of a decreases and the power of b increases in each term. For a, the powers are 3, 2, 1, 0 and for b, the powers are 0, 1, 2, 3. Let's try and generalize a formula for this. Consider a plus b raised to n, where n is any positive integer. First, let's write the binomial coefficients given by the formula of combinations. So we have NC0, NC1, NC2 and so on up to NCn. We've left gaps here because the terms are not complete yet. We can complete the terms now. We know that the power of a decreases from left to right. So let's write a with each term having decreasing powers. We have a to the power n here. How do we write the power of a in the second term now? Yes, as the power decreases, we can write it as a to the power n minus 1 and then a to the power n minus 2 and so on. The last term will not have a as it's a raised to 0, which is nothing but 1. We're not done yet. What about b? We write b with each term having increasing powers. That is from 0 to n. So can you complete the formula now? Here's how it will look. The first term will have b to the power 0, which is nothing but 1. Then we have b to the power 1, which is b, then b squared and so on. The last term will have b to the power n. There you go. We have the general formula which will help us expand the binomial of any power very easily.
Now we will solve it, as we know that the value of NC0, it is written as factorial n divided by factorial 0, then n minus 0 factorial. We can solve it. As we solve it, it is factorial n divided by factorial n, because the value of factorial 0 1, so it is 1. Similarly, we can find the value of NC1. Similarly, we can find out the value of NC2. That is now we will substitute these values in the expansion of the binomial theorem. And equation 1. This is equation 2. Now from equation 1 and 2, we get another expansion for the binomial theorem. So this is the another form of the binomial theorem. That this is equation 3. Later on we will discuss some other form also of the binomial theorem in special cases. Let a is equals to 1 and b is equals to x, and we get 1 plus x raised to power n is equals to 1 plus nx plus n minus 1 divided by factorial 2 x square, and in the same order last term will be x raised to power n. That is the another form of the binomial theorem. Let this is equation 4. Now there are some other special cases. Let the value of power is negative. So we write 1 plus x raised to power minus. In this situation, we get 1 minus nx plus n plus 1 divided by 2 x raised to power 2 and minus n plus 1 n plus 2 divided by factorial 3 x cube, and in this situation the last term will be infinite. In this condition the number of terms will be infinite. In previous one, in this one, number of terms will be n plus 1. Now another case, if we have 1 minus x raised to power n, then it is written as 1 minus nx plus n minus 1 divided by 2 x square, then minus n minus 1 n minus 2 divided by factorial 3 x cube, and the last term will be minus x raised to power n. Now another case, if there is 1 minus x raised to power minus n, and it is 1 plus nx plus n plus 1 divided by 2 plus n plus 1 n plus 2 divided by factorial 3 situation, the last term will be also infinite. So these are some special cases of the binomial theorem. Use of binomial theorem in physics is very limited. It is used when the second term x means the magnitude of x is very less than 1. In this situation, we will write in place of 1 plus x raised to power n only 1 plus nx, and for 1 plus x raised to power minus n only 1 minus nx. When we apply this case of the binomial theorem in physics, then we will also write using binomial theorem and then neglecting the higher terms.